So in terms of what we already covered, we actually covered a lot last week. So if you guys are not feeling confident because of the amount of information that I threw on you guys last week, I highly recommend you go watch last week's video because there is a lot of information packed in that 1 hour. Let's go ahead and actually just take a look at these, a summary of protocols from last week. We've talked originally, we only talked about IP. That was from maybe 3 weeks ago, actually. The Internet Protocol, which is a set of rules for governing the format of data sent over the internet or other networks. So this is just the basis of a packet, like how a packet is split up. This is like a very basic component. But we also talked about how there's so many issues that can arise when you're only using IP. So we discussed that maybe you send multiple of a packet, of like a singular packet, or maybe a packet gets lost. How would you deal with that? Then in that case, we introduced two things. We have the TCP and the UDP. The UDP, although it is faster, it doesn't solve many problems. It solves few problems, whereas the TCP is more dense in terms of the things that it can handle. So it is, it not only like checks for errors, so like anything that is corrupted, it not only checks for that, which UDP does check to see if data is corrupted, but that's pretty much it that it does. TCP will check for data corruption, it'll check for missing packets, it'll check for multiple packets, it does a lot more. So that's why we normally see it called TCP IP, because TCP is used along with IP or like kind of added on top of IP in order for it to work better, in order for it to create a more fault tolerant internet. You guys should know what that term fault tolerant means. We also talked about DNS, the domain name system, in conjunction with HTTP, Hypertext Transfer Protocol. HTTP is the protocol used for transmitting web pages over the internet. So that client server model that we had talked about before. So client server model, if you recall, yes, here we go. So you, the client, are requesting information from a server. So you will send a request over the internet and the server will respond by sending it back to you. This is the client server model. And then we also have the DNS, the domain name system. We talked about the IP address, how every computing device is assigned an IP address. And when you are trying to access a specific website, you do not have the IP address memorized. You normally input a URL. This URL, or specifically, I guess when we talk about the URL, a URL has different components to it. We have the big thing right here, the domain name. And within the domain name, there could be different subdomains. But regardless, if you're looking for a very specific web page, that is your URL. In order to access a specific web page, you also need to know the IP address for this web page. What DNS will do is look up the IP address using the domain name. The entire process, the domain is, well, oops. This entire process is started by the DNS. So DNS is a smaller network that make up the internet that contains many servers that act like phone books. And then I also compared it to like a dictionary, where a dictionary has a word and then a definition associated with it. This is something similar where we have a URL, or sorry, a domain name and the IP address associated with it. In total, we have 13 root name servers. So root name server is a little different from a name server. So a root name server is a type of name server, but not all name servers are root name servers. A name server contains IP addresses with the domain name. So it has that, it's like that, it's the dictionary that I had talked about earlier. But not all name servers act like root name servers. Root name servers contain every single domain name and IP address in the world, whereas most name servers might not have all of them, they'll have some of them. In the case that's the name server that is being checked does not have the domain name that you were looking for, then it could check another name server until eventually maybe you will have to check a root name server because a domain name that you're looking for is not being contained in the name service that was originally checked. So we have root name servers as a backup in case that the domain name is just a little bit difficult to find. So we also talked about how everything works. So when we talk about when you try to go on the internet, when you try to look up, when you try to like find something, when you try to go to a specific web page, how this is being done. So let's walk through this one more time, and then that'll be the end of our review. So for starters, you type a website, a URL, but also keep in mind that the URL is not the domain name. That is including the domain name, but it's not the IP address. So it's not the IP address. So you have to find the IP address before you could send your request for information. Remember that client server model, you need to send your request to the server, but you don't know what the IP address for the server is. So that is a huge obstacle. Fortunately, in terms of what has already been set in place, we can find the IP address. First of all, you send the data, like that URL, to your router/modem. Remember, we talked about very quickly how most of this device is like, normally both of them include, like your device at home contains both of them. The router will send the data to your internet service provider. So if it is like AT&T or Verizon or Spectrum, it'll send it to your internet service provider, your ISP. From there, the ISP will send it to a network, a DNS network, to look for your the domain name and to ultimately find the IP address. So the DNS and ultimately is going to look through the different name servers. If it can't find it in the first name server, it'll look at another name server. Worst case scenario, it will look at a root name server to find the domain name and ultimately the IP address. But when it does find the IP address, then it's going to send it back. So it sends the IP address back to the internet service provider, back to your router. Now you have the IP address because of this domain name system. Now that you have the IP address, you are able to forward your request to the server, to the domain, to the IP address, or to the server that has the IP address. So now you have the IP, and now you can send your packets to that server. So let's see. So we can have multiple packets. Let's say I have packet number 1, packet number 2, and packet number 3. Packet number 1 can travel like this. Let's say this is the end goal. The end goal is right here. It can travel like this. And now packet 1 has made it. Packet 2 might not necessarily travel the exact same path. And we know that it might not travel the exact same path because the goal is to make it there as quickly as possible. If there is a lot of internet traffic concentrated in a specific area, the packets will try to avoid that area. Otherwise, it risks being lost, or otherwise it's just congestion. It gets slower. The next packet, instead of following the exact same path, might take a different path. Let's say it decides to take a path that looks more like this, just to make it to the same IP address. The third one might take a path that looks more like, I don't know, oh, it's the same thing. Let's just say it goes. Oops. It decides to go this way. It makes it here as well. But they all take a different path, but they all get to their final destination. We talked about what the issues were or what potential issues can arise in the case you decide to, or in the case like packets fail to make it there, but go ahead and review that all on your own. That's a little bit too much to talk about in our review. But once the server has received the request, it will send packets back to you. So you will receive packets in the same way that you have sent the packets. They will send the packets through the network, through the internet, so that it reaches you in the very end. So it's the same process. Oh, okay, yeah. Okay, new material. Let's talk about some keywords that you might have seen in real life already. These words, bitrate, bandwidth, and latency. These are 3 keywords that you're going to need to know that you might find already familiar, but let's break it down anyways. When you send digital data, everything is broken down into binary. Remember, binary just means, whoopsies, it's just zeros and ones. Oops, just zeros and ones, nothing too fancy. We had talked about breaking down other digital information such as text. We talked about images, numbers. Those are all that's all digital data. That's all broken down into binaries, as computers can really only understand ones and zeros. When we send this digital information to through the internet, there is some kind of limit as to how much you can send. And that's what, to describe that limit, we use the following words: bitrate, bandwidth, and latency, because otherwise we have an infinite amount of data that can be sent. But we know that's not the case. You guys have struggled with your internet. You guys have been probably raging and angry because your internet has died, or because your internet wasn't working as fast as it was yesterday. These are the words that you guys can use to describe that now. The number of bits that can be processed per second. So processed per second is called the bit rate. So how many bits are being sent per second? Normally, I would say when we describe internet speed, I would say we normally use megabits per second. A long time ago, I think it was 70, 100, maybe we would say 100 bits per second. Now we have megabits per second. Megabits, if you guys are not sure, that's like a million. We're talking millions of bits per second are being processed and sent through the internet. That's a lot compared to what it was before. So bit rate is the number of bits that can be processed or sent per second. The broader term is bandwidth. So bandwidth refers to the amount of resources available to transmit data and is usually measured in bit rate or frequency. So bandwidth is, I would say, the maximum bit rate. So when we talk about amount of resources are available to transmit data, that's like the best case scenario, how much, what your bit rate would be. You cannot go beyond your bandwidth because that would exceed your best case scenario. Latency is not like bandwidth and bit rate. Latency measures, instead of how fast something goes, it measures the amount of delay. So the amount of delay when sending digital data over a network, but is more commonly understood as the round trip time information takes to get from the client to the server and back. So remember, we had a client server model where you are the client. That's you. And then you had your server, the server where you're trying to request your information from. That's the reason why you sent the packets in the first place. You wanted this IP address. The time that it takes for you to send your request and then for the server to respond to you, that entire cycle, that time is what we call the latency. These are typically measured in milliseconds and can be found by pinging an IP address or URL. This is probably something you guys want to know, that the latency is measured in milliseconds. So latency is just how late do the bits that you sent get how late does it take for the bits that you sent to be responded back to you? So sending and receiving, how long does that time take? So the three keywords for this slide: bitrate, bandwidth, and latency. Let's talk about another topic that is not very not talked about a lot when in terms of like high school, I guess. Cybersecurity. So what is cybersecurity? Cybersecurity protects our electronic devices and networks from attack and unauthorized use. So if you connect the two words cyber and security, that's pretty much what you get. When you think cyber, you often think about the internet. When you think security, you think about protection. So protects our electronic devices and networks from attack and unauthorized use. These attacks usually come in through an email, because what's more intrusive than email is something that could be transferred so easily along the internet. And when you receive an email, if you open an email, if you download an attachment from an email, now it's become internal. It's not just something that was, now it's not something that's just traveling in the internet. It's now something that you have brought into your computer, especially if you download an attachment from an email that ended up being something that we call malware. So mal, if you think about mal means bad. Mal means bad. And then ware is like software, hardware. It's like the actual, what do you call it? It's like a tool, I guess, but it's not a good thing that you want to bring into your computer. There's 4 different types of attacks that you guys should know. The DDoS, which is distributed denial of service. Phishing, I think this one you guys probably have heard a lot. You maybe not only in just emails, but maybe you've heard of like voice phishing, which is something that is done over a phone. Same kind of phishing, not with an F. We have computer viruses. You guys probably heard of this being tossed around a lot when people are saying, my computer has a virus. This is the same exact virus that we're talking about, but the one that you guys might not be familiar with is a computer worm. So let's talk about the differences between these 4 different kinds of attacks. So the first attack that we're going to talk about is the distributed denial of service, so DDoS. So this targets a web server. So not necessarily you. This isn't an issue for you. Typically, this is something that is normally for websites. So bigger, yeah, I guess like websites. So what will happen is that a web server is flooded with so many requests that it cannot handle them all, and ultimately the server will crash. I believe this has happened to a lot of government agencies as well. It's not just small websites. Like this has definitely happened with like the FBI's website, or it's happened to like the White House website. It's happened, I believe the biggest one, actually, I have to look this up again because it's been a while since when I looked into it. I think the biggest one was on GitHub. If you guys don't know what GitHub is a tool that is widely used amongst computer scientists, amongst computer engineers, amongst software engineers. But it's just a whole bunch of requests. Remember, client server model, multiple clients, so many clients or bots that are acting like clients are sending requests. They're flooding the server with a whole bunch of packets, a whole bunch of data. So that server cannot handle it all, and it will ultimately crash. Maybe you guys have tried to buy like tickets for like a concert ticket or something, and the website crashes. Something like that is happening, but this is being done on purpose to maliciously, or with malicious intent, to destroy a website. So that is DDoS. And then we have phishing. So phishing is creating emails and/or websites that look exactly like a legitimate site, hoping to induce a person to click on it. This often prompts the user for personal information. So whenever you guys get an email that, I mean, I get this all the time, like every day I get some kind of phishing email that will send, or some kind of scam that they're asking like, oh, like click on this link to change your password. And it's when you click on it, it might look like a legitimate website, but it's trying to get you to input your information that they can use for their own purposes, typically not good purposes. Um, Oftentimes, what will happen is the phishing or that email they send to you will have typos in it, or will have some kind of suspicious phone number or suspicious email or suspicious website associated with it. So for example, if you're getting something from Amazon, they might not send it to you from Amazon. They might send it to you from this. So there's different ways that they could send you emails, and there's different ways that there's different strategies to phishing pretty much. But ultimately, it's creating something that looks legitimate to fool users to give away some kind of information. Then we have computer viruses, something that you guys might be more familiar with. So computer viruses attach themselves to or are part of an infected file. They can damage, delete, or steal your files and use your system to spread to other devices. So this is a very broad thing. The key thing though is that it attaches themselves to or are part of an infected file. So a computer virus is part of something, whereas a computer worm is not part of an infected file, but they are the file. And they are the file. And the goal of a computer worm is a little bit different from a computer virus. So a computer virus is trying to spread to everything. So you might have a virus, you might like it might be part of like let's say you have an email and you forward that email to someone else. Like there's a virus as an attachment. Now it's been spread. So that's similar to a goal of a computer virus, whereas a computer worm is a little different because it's not part of infected file, it is the file itself. And they can make endless copies of themselves and do not need a file to be spread. So computer virus is trying to spread amongst files, it's trying to spread amongst people as it gets sent. Computer worms makes copies of themselves and they don't need to be spread through files because they can make copies of themselves. So these two are two different things. Oftentimes, they are used or it's not used interchangeably. Most people will just call a computer worm a computer virus, but there is a distinction between the two. So those are four types of what do we call it? There are four types of attacks. There are four types of attacks. One field of study is cryptography. Cryptography is a lot of math. So if you guys like math and you guys also like cybersecurity, this might be for you. But cryptography is the writing of secret codes. The reason why we're able to have secured online shopping and keep our data in cloud accounts. So if you guys have iCloud or Google Drive, the reason why you're able to have that is because they're secured with our passwords. But let's say you have your password. Someone hacks the database. Now, ideally, they should have everyone's passwords, right? That's what like the common line of thinking is. So if I have like, let's say you have, here's a database with everyone's account info. So we have the person's name and then their email and then their password, right? Like that's what a lot of people are under the impression is like what a database will look like. But the truth of the matter is, even though that information is contained inside of a database, this is all encrypted. So when someone gets a hold of that information, it just looks like gibberish. It doesn't make sense to them because it is been written in some kind of secret code. So um, we unfortunately, the type of encryption that this is normally done in is out of the scope of our class. In fact, I am not too familiar with it either, but actually, do I talk about it? Okay, I talk about it a little bit. So we'll talk about it just a little bit, just a little taste of it, but we won't be able to go into it in a lot of detail because it is a little bit more complex. Um, but we will talk about a simpler encryption method called the Caesar cipher. But before that, let's go ahead and talk about a little bit more vocabulary. So encryption is the encoding of something, whereas decryption is the deciphering of this encoding. So decryption is the opposite of encryption. Encryption is when you're encoding. Decryption is when you are changing it back into the original message. Ciphers, ciphers are coded messages and they have two parts to it. The first one is the key and the second part is the algorithm. So the key allows the creation of secret messages. An algorithm is a set of steps used to translate the message to be unreadable to anyone but the person who holds the key. So in a way, the key is like a rule and the algorithm is a set of steps to implement it based on the rule. The easiest cipher that I could introduce to you guys is the Caesar cipher. So it's one of the first examples of ciphers and it's a symmetric cipher. A little bit more about that. Let's talk about the Caesar cipher really quickly though. So the Caesar cipher utilizes the alphabet and it's like the ASCII table if you think about it. The ASCII table has some kind of numerical encoding for every single value. For every single letter, I guess. So when we think about A, that would be 0 instead. B would be 1, C would be 2, D would be 3, E would be 4, F would be 5, E would be 6, H would be 7, I would be 8, J would be 9, K would be 10, L would be 11, M would be 12, and we'll stop actually. N would be 13, O would be 14, P would be 15, Q is 16. Please let me know if I mess up, if I've missed a letter. T would be 19, U would be 20, V would be 21, W would be 22, X is 23, Y is 24, Z is 25. That looks right, right? The Caesar cipher shifts everything by 13 letters. Oh no. Shifts everything by 13 letters. So let's say I have hello. Then, actually, let's get rid of the exclamation mark. Then when we take a look at the H here, H is 7. We shift everything by 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now it is U. When we have E is currently 4, we shift everything by 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now it is R. When we have L, so we actually have L, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's Y, because we have two L's. And then we have O. We just shift it by 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is B. So hello using the Caesar cipher is URYYB. Pretty easy cipher. The reason why you don't see the Caesar cipher in the real world is because it's so easily decoded. It's very obvious, like you could explain this to an elementary school student and they would probably catch on very quickly what's going on. It's very easy to encode. As a result, it's very easy to decode. There's also a lot of different like you could solve it through without computer science knowledge. All you need is some linguistics knowledge. It might take a little bit longer, but let's say, for example, you're given an entire message, like an entire paragraph. You might be able to guess which one is supposed to be I or which one is supposed to be A because those letters show up a lot on their own. For example, like I like dogs. That first letter I is like a singular word. So people using linguistic analysis might be like, okay, so this one is supposed to be probably an I or an A because A is often shown up on its own. And they might be able to use that to their advantage to decrypt a specific message. So this cipher is not very useful. In fact, all symmetric ciphers, so remember symmetric cipher, a symmetric cipher means that you use the same exact thing to encode and decode. So in our case, I encoded using a key of 13, right? Because you shift everything by 13 letters. And then for our algorithm was to shift by like key letters. In our case, remember key is 13 though. So if I want to decrypt, I just need to shift backwards. This is why it's symmetric because what I do forward, I do the same thing if I want to go backwards. So not a very good algorithm or cipher to use if you want something with foolproof security, which is why we have something called public key encryption. Symmetric encryption uses the same key to encrypt and decrypt, making security very weak. We just discussed this. That's the reason why a lot of systems use public key encryption. So public key encryption is an asymmetric system, meaning you use one key to encrypt and one key to decrypt. So one key is used to encrypt it and another used to decrypt it. Whereas here we use the same exact key to encrypt and decrypt. We just use 13. This is different because you use one to encrypt and one to decrypt. We have something called a public key and a private key. So a public key is exactly what it sounds like. It is openly published and available to anyone. Anyone can see the public key. But without the private key, they are unable to decrypt it. So the thing that is usually used is that the public key is used to encrypt, whereas the private key is used to decrypt. Because the public key is readily available to anyone, all they can do is encrypt. The private key, however, is needed to decrypt something, which is why when we have this database right here, it's useless because they might have the data, they might have the encrypted data, but they do not have the private key to decrypt it. So that is the system that is mostly used today. We use public key encryption as opposed to a symmetric encryption because it provides more security. It is more difficult for someone to decrypt into a message or into text that they can understand. So yes, the receiver decrypts with their with the private part of the key. And that is going to be it for today's lecture. I think I have some summaries. Yes. Okay. So takeaways. So the summary for this entire internet unit. The internet is a network of networks. A network of networks because we have, like, let's say we have one network over here and then another network over here. These two can be connected and now you have a network of networks. And this is typically how our internet, this is how our internet is designed because we have multiple internet service providers and those internet service providers focus on their own specific networks. However, if necessary, they do also connect with each other. This allows us to have the internet as we know it as today. The internet is fault tolerant. You should know why. So we talked about the TCP/IP, which is a very big reason why the internet is fault tolerant, but also know that the internet is repetitive. Things can take a different path and they could still end up at the same exact place. There are rules, aka protocols, for connecting and communicating on the internet so the correct sites can be found. We went over this in our review earlier as well. And finally, the last three things that we talked about for today: cybersecurity, malware, and cryptography. When I say malware, there were two types of malware that we talked about. We had the computer viruses and the computer worms, but there are also two attacks that we talked about, two additional attacks that we talked about, the DDoS, as well as, sorry, there was something happening over in this corner, DDoS, as well as phishing. And then finally, today we talked about cryptography. We talked about the symmetric encryption and asymmetric encryption. Symmetric encryption is great, but it is so easily cracked that what we resort to now is something called a public key encryption that uses two keys, a public key and a private key. Public key anyone can have access to. It helps them encrypt, but the private key is what is going to be important for our decryption. That is the reason why people use public key encryption instead of just a symmetrical encryption.